The B-17 is losing oil at 12,000 feet. The number 3 engine is bleeding black streaks across the wing. In 4 minutes, maybe 5, the propeller will seize. Then the bomber falls. The pilot calls for bailout preparation, but the flight engineer is already moving toward the engine nacelle with a tin can, a hacksaw blade, and a piece of leather cut from his boot. What happens in the next 11 minutes will be dismissed as impossible by every maintenance officer who hears about it, until 6 more bombers come home using the same method. The year is 1943. The 8th Air Force is bleeding over Europe. Every raid into Germany costs bombers and crews at rates the planners never imagined. Fortresses limp home on 2 engines, sometimes 1. They ditch in the Channel. They crash land in fields across England. The lucky ones make it back to hard stands where ground crews swarm like surgeons over dying patients. At Bassingbourn, the smell is oil and hydraulic fluid and burnt metal. Mechanics work through the night under hooded lamps. The cold bites through coveralls. Fingers go numb on wrenches. There is mud everywhere, frozen in the mornings, slick by afternoon. The bombers return from Bremen or Schweinfurt with holes you can crawl through, wings shredded, tails nearly severed, engines trailing smoke. The ground crews are farmers and garage mechanics and kids who learn to fix tractors. They are not engineers. They do not have diagrams for every failure. They improvise with what they have because what they have is never enough. Parts are scarce. Replacements take weeks. So they patch, they weld, they cannibalize wrecks to keep others flying. And every morning before dawn, they watch their work take off into the dark. Some come back, some do not. There is no separation between the ones who fly and the ones who fix. They are all in it. They all know the math. They all count the empty hard stands at dusk. If this history matters to you, tap like and subscribe. His name is Technical Sergeant Howard Emery. He is 24 years old. Before the war, he worked in a machine shop in Akron, Ohio. He repaired industrial presses, steam fittings, conveyor systems. He learned not from manuals, but from watching metal fail. How a bearing wears, how a gasket splits, how pressure finds the weak point and exploits it. He does not talk much. His crew chief says he listens to engines the way a doctor listens to a heartbeat. He can tell when a cylinder is misfiring before the instruments show it. He knows the difference between a valve problem and a fuel problem by the color of the exhaust. He carries a small notebook in his chest pocket, filled with sketches and notes. Not official maintenance logs, personal observations, things he has noticed. Emory is a flight engineer on a B-17 called Maiden America. His station is between the pilot and the top turret. In flight, he monitors 4 engines, fuel flow, oil pressure, hydraulic systems, electrical panels. He adjusts mixtures. He transfers fuel to balance weight. He is the one who decides if an engine can be saved or must be shut down. The pilots trust him because he has kept them alive. On the ground, he works alongside the mechanics. He is not required to. Flight engineers usually rest between missions, but Emory wants to see what breaks and how. He wants to understand the failures so he can prevent them at altitude. The crew chief lets him in because Emory does not pretend to know more than he does. He asks questions. He watches. He learns. There is a problem no one can solve. Oil lines crack under vibration. They crack at the fittings where the line meets the engine block. The threads strip. The seals fail. Oil sprays across the nacelle, and once it starts, there is no stopping it. On the ground, it is a 4-hour repair. In the air, it is a death sentence. The official procedure is to feather the propeller and shut down the engine. Most of the time, a B-17 can make it home on 3 engines, but over Germany, with fighters and flak, Losing one engine often means losing another, and two engines on the same wing means you cannot hold altitude. You fall behind the formation, and once you are alone, the fighters come. In February of 1943, the 8th Air Force loses 60 bombers in 2 weeks. Many are lost, not to direct combat damage, but to cascading mechanical failures. An oil line cracks. The crew shuts down the engine. They lose speed. They lose altitude. Then something else fails. Then they go down. The engineering staff issues bulletins. They recommend inspection intervals. They order replacement hoses from the States. But the hoses do not arrive, or they arrive in insufficient numbers, or they are the wrong specification. Meanwhile, the mission schedule does not stop. The bombers fly every day the weather allows, and every day some do not return. Emory sees it happen on a raid to Wilhelmshaven. A fort in the low squadron loses oil pressure at the initial point. They shut down the engine. 10 minutes later, the number 2 engine overheats because the formation is throttling up to evade flak, and the remaining engines cannot sustain the load. The bomber drops out. Fighters swarm it. No chutes are seen. Back at Bassingbourn, Emory walks the hard stand where that crew used to park. Their names are still stenciled on the nose. Someone will paint over them soon. Someone will assign a new crew. But for now, the space is empty. He thinks about the oil line. The failure is always the same. The threads are fine. The hose is intact. But the joint where they meet cannot handle the vibration. The engine shakes. The fitting loosens. The seal breaks. And once the oil is gone, the engine destroys itself. The official solution is to replace the fittings with a reinforced model. But those fittings are not available. They are on order. They have been on order for months. In the meantime, crews are dying. Emory asks the crew chief if there is any way to reinforce the joint in the field. The crew chief says no. The threads are machined to a tolerance. You cannot shim them. You cannot wrap them. Any modification would compromise the seal further. Emory asks if anyone has tried. The crew chief looks at him. No one has tried, he says, because it would not work. 3 days later, Emory is in the machine shop at dawn. He has a damaged oil fitting from a scrapped engine. He has a hacksaw, a file, a set of calipers. He is trying to understand why the threads strip. He measures the depth of the threads. He measures the pressure the oil pump generates. He calculates the force on the fitting during normal operation and then during high-power climb. The math is simple. The force exceeds the tensile strength of the seal under sustained vibration. It is not a matter of if the seal fails. It is a matter of when. What he needs is something to distribute the load, something that sits between the fitting and the housing and absorbs the vibration without blocking the flow. He considers rubber, but rubber degrades under heat and oil. He considers cork, but cork compresses and loses its shape. He considers thin sheet metal, but metal will not conform to the threads. Then he thinks about leather. Leather is used in pump gaskets. It swells slightly when soaked in oil, which helps it seal. It is tough enough to handle vibration, but soft enough to conform to irregular surfaces, and it does not degrade quickly under heat. He cuts a thin washer from a piece of scrap leather. He soaks it in oil for an hour. Then he fits it between the hose and the engine block and tightens the fitting over it. The leather compresses but does not tear. The threads bite cleanly. The seal holds. He takes the assembly to the crew chief. The crew chief looks at it. He asks if Emory has lost his mind. Emory explains the logic. The crew chief says logic does not matter if it leaks at altitude. If oil sprays into a hot nacelle, the whole engine can catch fire. Emory says he knows. He says he wants to test it. The crew chief says no. Emory goes to the squadron maintenance officer. The officer listens for 30 seconds and then cuts him off. Unauthorized modifications are prohibited. If a repair is not in the manual, it does not happen. End of discussion. But Emory cannot let it go, because he knows what happens when an oil line fails. He has seen it. He has counted the empty beds in the barracks. On March 8, 1943, Maiden America is scheduled for a raid on Rennes. The target is a rail yard in Brittany. It is considered a lighter mission, less flak than the Ruhr. Fewer fighters than Berlin, but lighter does not mean safe. During pre-flight, Emory notices a small oil seep on the No. 3 engine. It is minor, within tolerance. The ground crew says the bomber is cleared to fly, but Emory knows that small seeps grow into big ones. He asks if they can replace the fitting. The crew chief says there are no spares. The bomber flies as is. They take off at 06:15. The sky is overcast. They form up over the channel and head south. At 10,000 feet, the No. 3 engine starts losing oil pressure. Slowly, a few pounds per minute. The pilot asks Emory for his assessment. Emory says they can make it to target if the leak does not worsen, but if it worsens, they will have to shut down over France. At the initial point, the leak worsens. Oil pressure drops from 60 pounds to 40. The pilot asks again. Emory says they have maybe 10 minutes before they have to feather. The bombardier says he needs 6 minutes for the run. The pilot says, make it fast. They drop their bombs. They turn for home. And the oil pressure drops to 25 pounds. The engine is screaming now. The temperature gauge climbs into the red. The pilot tells Emory to shut it down. But Emory is thinking about the leather washer. He is thinking about the test he was not allowed to run. And he is thinking that if he shuts down the engine now, they will limp home on 3. And if anything else goes wrong, they will not make it. He tells the pilot to give him 5 minutes. The pilot asks what he is going to do. Emory does not answer. He is already moving aft. He opens the access panel to the engine bay. The noise is deafening. The slipstream pulls at his clothes. He can see the oil line vibrating. There is a mist of oil coating the nacelle. The fitting is loose. He can see it wobbling. He has a piece of leather in his pocket. He cut it 2 days ago. He also has a safety wire and a pair of pliers. He knows this is insane. He knows that if the leather catches fire, he could lose the whole wing. But he also knows that if he does nothing, the engine is gone anyway. He wraps the safety wire around the fitting to hold it in place. Then he loosens the fitting just enough to slide the leather washer beneath it. His hands are slick with oil. The wind is tearing at him. He tightens the fitting as hard as he can. The leather compresses. The wobble stops. He watches the oil pressure gauge. It stops dropping. It holds at 15 pounds. Then it climbs. 20 pounds, 25, 30. The temperature begins to fall. The engine is still running. The propeller is still turning. The seal is holding. He makes his way back to the cockpit. The pilot is staring at the gauges. He asks what Emory did. Emory says he tightened the fitting. The pilot asks how. Emory says he will explain on the ground. They make it back to Bassingbourn. The No. 3 engine runs all the way to shutdown. When the ground crew inspects it, they find the leather washer still in place, soaked black with oil but intact. The crew chief does not say anything. He just looks at Emory. Then he takes the washer and puts it in his toolbox. Word spreads fast. Within a week, 3 other crews report using leather washers to stop oil leaks in flight. One engineer cuts his from a glove. Another uses a piece of boot lining. All of them work. None of them are officially authorized. The maintenance officer hears about it and orders an investigation. Emory is called in. He explains the principle. The officer says it is a field expedient, not a solution. Emory says it is a solution until a better one arrives. The officer says he will take it under advisement. 2 weeks later, a technical order is issued. It does not mention Emory. It does not mention leather. But it authorizes the use of secondary gasket reinforcement material for oil line fittings in emergencies. The material specifications include leather, cork, and rubberized canvas. Ground crews are instructed to carry pre-cut washers on all missions. By May, the modification is standard practice across 3 bomb groups. Oil line failures drop by 40%. The change is small, invisible. A washer the size of a quarter, but it keeps engines running. And engines running keep bombers in formation, and bombers in formation come home. No one tracks how many lives are saved by a piece of leather and a sergeant who would not accept the manual as the final word. There is no medal, no commendation, just a technical order buried in a file cabinet and a quiet understanding among the ground crews that sometimes the solution comes not from engineers in Ohio, but from a man standing in the wind at 12,000 feet with oil on his hands and no other choice. Emory flies 18 more missions. Maiden America is shot down over Hamburg in July. Emory and 4 others bail out. He spends the rest of the war in Stalag Luftwaffe. When he is liberated in 1945, he weighs 120 pounds. He does not talk much about the camp. He does not talk much about the war. After the war, Howard Emery returns to Akron. He goes back to the machine shop. He repairs presses and fittings and conveyor belts. He marries. He raises 2 children. He does not tell them about the leather washer. He does not tell them about the oil line or the engine bay or the 5 minutes over France when he made a choice that defied every regulation he had been trained to follow. His son finds the notebook in a box after Emory dies in 1991. The pages are yellowed. The sketches are faint. There are drawings of fittings and threads and pressure calculations. There are notes in the margins about vibration and load distribution, and on the last page, in pencil, a single line: "If the engine runs, the crew lives." That is the only specification that matters. It is not a philosophy born of heroism. It is a philosophy born of necessity. Of standing in the cold at Bassingbourn and watching bombers return with holes in them, and knowing that the difference between survival and death is often something small: a gasket, a fitting, a choice made in the moment when the manual offers nothing and the consequences are absolute. The leather washer modification is forgotten by the official histories. It does not appear in the technical manuals after the war. It is not taught at maintenance schools, but for a few months in 1943 it was the difference, and the men who used it knew. Emory never claimed credit. He never sought recognition. He did what made sense. He tested it when no one would let him. He used it when failure meant death. And when it worked, he moved on to the next problem. That is the kind of heroism that does not make headlines. It makes it home. In the end, war is not won by the brilliant or the bold alone. It is won by the ones who see a problem the manual cannot solve and solve it anyway, who trust their hands and their logic more than the voices telling them it cannot be done, who understand that survival is not a matter of following orders, but of knowing when to break them. The lesson is not that rules do not matter. The lesson is that rules are tools, not gods. And when the tool fails, you reach for something else: a piece of leather, a hacksaw, a refusal to accept that the men beside you must die because the correct part has not arrived. Howard Emery kept 7 bombers alive with a washer cut from his boot, and in doing so, he proved what every mechanic and engineer and stubborn problem solver already knows: that the distance between impossible and done is often just one person willing to try.